Welcome everyone. Today we are going to learn about the Kirchhoff voltage law and we are going to see it using an experiment on the NILV's prototyping board and LabVIEW together like we did in the previous experiments. As you can see on the screen on the left, we have implemented a circuit. I have drawn a circuit there consisting of a power supply Vs which is configurable in real time, and we have 5 resistances, each of value 1k, 2k, 3k, 4k and 5k respectively. Now as shown in the diagram, you can also see the circuit on the main board here. So the green wire here and the yellow wire here are meant for providing the supply. Yellow wire here, which I am pointing to now, is giving plus VCC to the circuit, and the green wire here is providing ground to the circuit. Now if you can observe carefully, this resistance is 1k, which is actually V1 in the circuit diagram, which across which the potential drop is V1, and the resistance here is 2 kilo ohm, across which the potential drop will be called as or referred as V2. These two resistance together constitute to 3 kilo ohm resistance, and across these two resistors we will find V3 to be our voltage. And the two resistors present here are constitute the resistance are 4k, and across these two resistance we call the voltage drop as V4, and across these three resistances present we are going to find the voltage drop V5, and they together constitute the voltage drop, the V5. Now we are going to apply dynamic voltages to the entire circuit by using the LabVIEW front panel, as I am showing it using the cursor. And as we change the voltage source values, we are going to measure each voltage drop V1, V2, V3, V4 and V5 using the DMM lines, these two lines, and we'll update them in the LabVIEW front panel. So we will see what is going to appear as V1, V2, V3, V4, V5 for a given input voltage Vs, and let us also see how the sum turns out to be. So first I am applying a 4 volt supply to Vs, and now I'll be measuring V1. So as shown on the DMM output here, which is changing continuously, we can approximate that the voltage drop V1 is 0.24. Now let us measure V2. Now let us change the wires. These two resistors constitute to the voltage drop V2, so let us place the positive wire of DMM here and the negative wire of DMM here. Oh, my mistake, sorry. Where I was to cut this out. So it is 0.545. Fine. Now we'll measure for V3. And it is coming out to be 0.79. Similarly, we'll measure for V4 by changing the DMM wires as shown. So we'll find the output voltage or the voltage drop across resistor 4 kilo ohm to be 1.09. And finally across find it to be 1.3. So if you observe carefully here, we got V1 as 0.24, V2 voltage as 0.545, V3 which is across 3 kilo ohm as 0.79. The voltage drop across 4 kilo ohm resistance is 1.09 and the voltage drop across 5 kilo ohm is 1.3. So all the sums V1 plus V2 plus V3 plus V4 plus V5 is shown in this text box. Sum of voltages is coming out to be 3.965. So if you observe here, the amount of voltage which we have applied is 4 volts and the sum of the voltages or the voltage drops across all the resistances in the circuit is coming out to be 3.965, which is approximately 4 volts. So the circuit actually proves that the sum of voltages in the circuit will always come out to be 0. So now we have 4 and there is a minus 4, the 4 of the source and the summation of voltage drop across all the resistors are in opposite polarities. One is in clockwise direction and another is in counterclockwise direction. So both of them will add up to 0. So in this way we can actually prove Kirchhoff voltage law of a circuit.